A very good evening to all. Welcome to Unacademy and to this channel. I hope all of you are doing great. Good evening. Audio and video, everything is fine to you now? Yeah, we'll continue the session 300 question series, which is the part 7. If anyone is new to this channel and you do not know about the profiles, visit this profile of mine, and also similarly you'll find a profile link for every educator, and you just follow your favorite educator, and then you will get the notifications of free and paid classes, everything whatever you require. So recently the crash course is started on 18th August. In case if you are not aware, you can start for data science and computer science, both of them crash course started. And in case if you are late in starting preparation, then you can start with this crash course. And also new batches started from 25th August. अगर आपको freshly start करना है आगे, तो आपको data science में Python programming है, 26 के लिए भी same है, और डेटा कंप्यूटर साइंस में आपको डिजिटल लॉजिक स्टार्ट हो रहा है बाय चंदन सर एट 2:30 PM. एंड आपको पता होगा ये प्राइस अभी जो अनअकैडमी अगर सब्सक्रिप्शन नहीं लिया, अगर लेना चाहते 6 मंथ्स के लिए आपको ऑफर चल रहा है अभी 8,499. ये ऑफर 25 अगस्त तक है, और 1 ईयर के लिए भी ऑफर है 11,999. अगर 2026 के लिए प्रिपेयर करना है, ये 1 ईयर का लेना. अगर आप 6 मंथ्स में कंप्लीट करना है तो ये 8,499. द कोड आपको यूज करना होगा CSDA. Also, if you want to write the scholarship test, if you want to attempt, there is a monthly scholarship test. You can use this QR code to enroll for this. The test is on 25th August at 11 AM, and duration is 30 minutes, and you will be having 20 practice questions. This scholarship you will get a chance to avail up to 100%. And test series for computer science, data science, both are launched on Unacademy. In case if you have not taken this test series, you can enroll for this. And if you have already taken the subscription, this is a part of the subscription. If you just want to take test series, then apply the CSDA code. But computer science and data science both are different tests, so you have to purchase separately. If you want only CS, you can do that. If you want only data science, you can also do that. Yeah, we ready? Have you done homework question lately? Yes, gamers. Not now. We'll do after 2 months. Okay, one short series, and or I may do it once I complete the old TOC and compiler. I'll also do that one shot. Yeah, we can go for that. Will help you to prepare quickly. We'll plan for that. Wait till then. What is the answer for this? I told you, right? Just take this as A comma B, no? The first question. Which of the following are regular? The timer is not required as it's a homework question. How many of you answered this is? Can look at this. You can put here n is equal 0. When you put n is equal 0, you will get the whole language is just A plus B whole star. Now, whatever you put n is equal 1, 2, 3, 4, then W already covered your strings. Then this dominates every other n. N is equal 1. Whatever you get, that is like L is equal to, of course, the whole language I'm writing here. Just take expression first. A plus B whole star first one, and n is equal 1 you will get A, and A plus B whole star B. But this is already covered inside now. Similarly, n is equal to also will covered inside whatever you get here. That's a square w b square is also covered here. So when you combine all of them, what will you get? A plus b whole star. Okay. So a is regular. What about b? Can you try similarly b also? And let's try this. When you put n is equal 1, because that is a minimum, right? So यहाँ पर क्या आएगा? a plus b whole star b. Now my question is, if I put n is equal to, then I'll get a square, a plus b whole star b square. Will it cover? Is it covered already here? Yes. Is it covered or not? Yes, it's already there inside, because starting with a ending with b strings. Yet this is also doing starting with a ending with b. Similarly, n is equal 3 happens. It's also covered here. So this expression you will get as starting with a and ending with b. And this is also regular. And what about c? C is, when you put n is equal 0, you will get a plus b whole plus, because sigma is a comma b, right? And n is equal 1, whatever you take is already covered. N is equal 2 also covered. So C also regular. And what about D? When you put n is equal 1, a plus b whole plus b. And now you just cross check, n is equal to whatever you write, is it covered here? N is equal 3 also, and so on. So here the answer is starting with a ending with b, but minimum 3 length. Minimum 3 length. All are regular. Anybody answer that? A, B, C, D. Okay, do not compare this problem with other things, because this is a special pattern. When we change the pattern, this may look different. That's why I have given homework. Just work on it. Let's see who will answer A, B, C, D. All are actually become regular because of the pattern. The W was helping to give you all strings. Understood by everyone? Next, I'll give the timer to solve like this. Let's see who will do it. Use a similar approach what I have done so far. इसके लिए 2 मिनट दे रहा हूं, क्योंकि 4 ऑप्शंस को वेरीफाई करना होगा. Previously W was in the middle, now W is in the first. It's a different concept. Okay, here don't say the 4 may not work here. All options may not be correct. Don't forget to like the session and also share this session with your friends, so that many people can join and they can get benefit from this series. I believe that this kind of questions you may not find even in test series, some of the other test series. So definitely it's a good question. And can see. Let me check. When you put n is equal 0, what will you get? You'll get a plus b whole star. And is it covering everything? Oh, you can believe this is also URL, correct? Because n is equal 1, 2, 3 is inside only. So definitely this is regular. Here put a comma b, as I said yesterday. So keep that data change. Okay, let me help you. We already changed the data now for all of them. Forgot to edit this. The homework I already mentioned it. Okay. And now this one, when you put n is equal 1, what happens? When you put n is equal 1, that's only the minimum possibility, right? You will get a plus b whole star followed by ab. But is it covering n is equal to? No. What is n is equal to? A plus b whole star followed by double a double b. Oh, that was ending with ab. This is ending with something different. Ending with a double b. This was not covered. Similarly, n is equal 3 also something different, which was not covered by the first two. It's a new form. And n is equal 4 also something new. And every value of n is new. That means dependency always there. There is no single expression to cover all of them. So this is not regular. And C is similar to the A, because this one you will get when you put n is equal 0, you will get a plus b whole plus. And that's your language, because remaining all values of n, the forms covered in this language, in this expression. Okay. And D, is it similar to the this one? B, yes. N is equal 1, you will get a plus b whole plus. That's it. But this is also not regular. Similar to the option B. A and C correct. To answer that A and C, proof answer. Last question in this model. Now W is last. First or last will give you the similar concept. Only in the middle you got a different one. All of 4 options were regular that time. And see, just what is changed now? W is at the last. That's it. So I'm going to stop this. So now A and C, which is similar to the previous question. As you can see, this answer will be a plus b whole star, and this answer will be a plus b whole plus. And B is not regular, and D is also not regular. HE2. Solve it. We'll do that. Number of A's equal to number of B's, and everywhere same. All are same problems? No, right? Only condition was same, but your string form is different. W belongs to different strings. Taken in even practice batch also. It was a good question. How many of, how many? 1, 2, 3. Even I didn't ask which one is regular here, right? A numerical answer type hai. Out of 1, 2, 3, which is right? Number 1, number 2, number 3. Here, how many are regulars? All of them or one? Which one that is? What is the numerical answer type? How many? Is the right answer? Two regulars are there. Out of 3, 2 regulars. What are they? 2 and 3. And how is that possible? This one, in whole world a plus b whole star, the number of a is equal to number of base. यहाँ पर आपको special strings दिखेगा, epsilon, a b, b a. You have to be very careful while writing the string, है ना? So there is a dependency between the symbols in string because string order is unknown. And what else? When a comes, when b comes, how do you remember? It's very difficult. If there are 1000 a's comes, then 1001 states required. Then again 1000 b's, then you have to verify. 1000 at least, let's say 2000 states or 2000 nearby, you may take DFA to design. But if I ask 1 lakh a's followed by 1 lakh b's, then very difficult to understand. Okay, you cannot keep changing your DFA. The infinite states required to understand this problem if you are following finite beta concept. And the next one, how many realized it is just same as AB whole star? Because W belongs to AB whole star, and every string that you take, is it having equal number of A's and B's or not? Because W cannot take any other string except AB whole star form. All the strings are already having equal number of A's and B's. So that means language is AB whole star. That AB whole star is already regular. And the third one is same as BA whole star. And these two are regulars. And this is regular. But this one, there is dependency between A's and B's that you cannot write an expression. Okay. So out of 3, 2 regulars, they are 2 and 3. Question is, how many languages are regular here? Out of 3, 2. Was given homework, na? Just tell me what is the right answer. How many of the following languages are regular? So if you have SBI account number, you have particular number of digits, right? 11 digit account number, 12 digit, 13 digits. So you have a specific account number throughout India. So now the SBI account number has a fixed length. Assume 11 digit number. The 11 digit numbers are there. So this is a finite language or not? How many 11 digits you can form in the 0 to 9 whole star? You will have, this is a finite language. You know, every finite language is regular. And Indian PAN number, even that is going to have fixed number of digits. Do you know how many digits in Indian PAN number? 10 digits. 10 letters. Includes digits as well as letters. Letters and digits. Combination of that. It is also finite language. Only finite number of PAN numbers are there in India, correct? Other number is also same, similar to this. It's also finite language. And how many languages are regular? You know, every finite language is regular. So answer is 3. All are correct. All are regulars only. How many of the following are possible to design using finite automata, to represent using finite automata? Identifying keywords in a given C program. C programming, how many keywords are there? 32 keywords. So 32 keywords, can I write an expression? Like int, float, something like this. Plus, you have, right? All of them you can write. Break, continue, and so on. How many are there? 32 keywords only, no? So 32 words you will write, and you can design regular. This is a regular expression total, right? The regular expression. For this you can design a finite automata, no issue at all. So it is possible to design. And can you try remaining like this? Tell me how many of them? Only one. And verifying the syntax, you cannot have a finite automata. You need a stack to understand. Finite automata has no stack. Okay? And checking the declaration of a variable before its use के लिए semantic analysis चाहिए होता compiler के अंदर, तो उनके लिए और one stack से भी possible नहीं होता, और knowledge चाहिए होता. Finite can help only the first statement, that is representing that pattern with the help of regular expression, and then you can design a finite automata for this. Answer is 1. Which of the following is true? I'll give you two minutes. Critical question, right? Analyze it and don't blindly answer any theoretical question. As you know, theoretical question requires much effort than the problems. Problems just you can solve, practice, you can remember the approach and solve it. But theoretical concepts takes time to interpret. You have to understand. I will not tell you now that Shubham was right. Something. First one. Answer is closure property will give you, look at, if L is regular then complement of L is regular, so closure property, that is, we know if you have a regular, you can design a DFA and you can interchange final and non-final, you can get another DFA, and this definitely does complement of regular. It will definitely accept complement of regular. So if L is regular, then L complement also regular, no doubt about it, because both will have a DFA. So it's true. If L is regular, then L star is also regular. This is a 𝐂𝐚𝐴 closure. 𝐂𝐚𝐴 closure is closed for regulars. And how you do it? If you have L, you can design a DFA or NFA, whatever. You can design any finite automata and you can apply some property. Which property? If you have some initial, if you have one final, and assume you design a finite automata. So now you can design the 𝐂𝐚𝐴 closure machine for this finite automata. How? You create new initial and you create a new final and make this as a non-final and give epsilon transition from here to here, and you can repeat this and you can add epsilon transition here. This makes 𝐂𝐚𝐴 star. So for every regular, the 𝐂𝐚𝐴 star will also be regular because both will have a finite automata. If L has a finite automata, then L star will also have a finite automata. That's why this closure property is also closed and it is true. You will get finite automata by using algorithm and for 𝐂𝐚𝐴 star. L star. This accepts definitely L star. And if complement of L is regular, then L is also regular. Look at this. If this is regular, then Even reverse direction also you can do the same. Same thing will get back to L. If L complement is regular, L is also regular. If L is regular, L complement is also regular. So this is also true. But the problem is the last one. L star is regular doesn't mean that L is regular. Suppose somebody designed L star, then you have no algorithm to convert to the L motion. So what is the example that L star is regular but L is not regular? Example, A power prime, its 𝐂𝐚𝐴 star is regular. Assume this is L. Okay, let's say L star only. L star means A power prime whole star. And for this, L is equal to A power prime. And look at this. L star is regular because we have a DF. This is exactly equal to A power n such that n not equal to 1. And this, when you try to derive the strings, except 1a, every string is here. But when you write the only A power prime, you don't have a finite automata. So this statement is false. If L star is regular, then L need not be regular, actual statement. So here instead of is, you should have need not be regular. So this is a false statement. So you will choose A, B, C. Got it? So I will wait for the answers, then no timer now onwards, okay? I'll give you time to answer it. Which of the following operations are not closed for infinite languages? What do you mean by not closed? When you take infinite languages, at least one time the result will be not infinite. Means you should get a finite. Is there any possibility of finite language when you take infinite languages? Infinite union infinite. Is there any possibility of finite? Never. Because always finite. Identify which are not closed. Is it union, intersection, difference, subset? That was right. Explain. So look at here, infinite language, union, infinite language. Is it always infinite? If it is not always, then that's not closed. Always infinite, that means closed. It means union is closed for infinite languages. Now this one, infinite language minus infinite language, will you get infinite? Need not be infinite. That means you have sometimes finite also. Which case, take the same language A star and delete the A star only. You get pi, right? Pi is not infinite, you know that. Correct? So this operation is not closed. If you get always finite, then always infinite, that is only closed. But here you cannot prove always infinite. Intersection, infinite intersection infinite language. Can you prove always infinite? No. Example, A star intersection B star. And what will you get? The result is only epsilon is the common. You got a finite language. When I take infinite, but after performing intersection, you did not get infinite. This example is enough. Why need not be infinite? Because if you want infinite, you can take the same language, you can prove infinite, but you're not getting always infinite. That's why the difference, right? Difference is not closed. Here intersection is not. example I have given for differences was correct. Like A star minus A star, you got empty set. Here A star intersection B star. Subset. When you take infinite language and do the subset, can you prove it is always infinite? No, right? Right. Subset of infinite language when you apply, you will also get need not be infinite. So it is also not closed. The question is about not closed. There are three example, you know, right? If I take A star, it is infinite language. But when you find its subset, even epsilon also it's a subset. Even empty language also subset. All are not infinite now. Finite. Okay? And some are finite, some are infinite. So B, C, D are not closed. Another one. This is something different, right? It's not about union, it's infinite union. First you should know what do you mean by this definition, each operation, then you apply the for the domain. So now again you should find not closed. Infinite union means infinite languages you should take infinite times. There are infinite languages infinite times. So now each language is infinite and you are applying the union infinite time. The result, you know, infinite union anything. Is it infinite? Yes, always. But here now every language is infinite. You are applying infinite times. So definitely infinite. So it's a closed. But we want not closed. Infinite difference. And I1 minus I2. You know, two languages only we have no guarantee. Now, can you guarantee? The infinite languages we have infinite times, we are going to take the difference, right? So result may be finite sometimes. How can you guarantee that? Suppose I1 same language A star minus A star, you got a pi here. Pi minus anything is pi only now. You may get a pi also, but pi is not infinite. So it's sometimes only infinite. You can say need not be infinite, may be infinite, may not be infinite. Intersection. So this is not closed. And infinite 1, infinite 2. And you know, if you don't have the common, you will get a pi. Example A plus and B plus. When you do intersection, you got a pi. And after that, you do intersection with anything, you will get pi only. Now here there is nothing common with the pi. So apply intersection, you will also get sometimes finite. This also need not be infinite. And infinite subset means you take infinite language. When you apply infinite subset, this is a not closed or closed? Not closed. Infinite subset means subset is always infinite. Okay. So I take, let's say, A star. When you find infinite subsets, let's say A power prime. This is an infinite language. Is it subset of this? Yes. Right. Result is always infinite and you can take any infinite. Infinite subset produces always infinite. That's the reason it is a closed. It is closed. Finite subset means result is the finite. Finite subset means result is infinite. Only B and C are not closed. A and D are closed. Now you need to work on closed for which domain? Regular languages. Very easy, right? Which is closed? You have the proofs why they are closed also. Remember two names, S and I. S means subset, I means infinite operations. Except them all are closed now. Very easy. Union is closed, difference is closed, and intersection is, and subset is not. You also have the proofs for them, very basics. 89. You need to find closed now. You know that infinite operations always not closed for regular languages. All of them are not closed. You cannot choose any one of them, right? Of course, in exam you will have at least none of this, so you can choose it. And no option matches because all are not closed. Which are given, not closed. All these options are not closed. You should have an idea. Blindly don't choose the options. You should have idea: infinite union, infinite difference, infinite intersection, infinite subset. When you apply the result, maybe not regular sometimes. Now you need to look at closed, but the domain is non-regular languages. Maybe we don't practice that in regular classes, but this is also very important. When you have only non-regular languages in front of you, and when you apply these operations, will you get a non-regular always? That is the question. Let's see. Now the question is like non-regular language 1 union non-regular language. What is the result? Can you prove always non-regular? That's the question, right? Let's look at. Right, I'll explain. Any two non-regulars you take, apply the operation, what will you get in general? Don't look at only one example. One example, look for not closed. But if you want to say closed, every example in the world should satisfy. Non-regular intersection non-regular. Will you get always non-regular? Subset of non-regular. You get always non-regular? Don't get it, not closed. Non-regular union non-regular. Is it possible any regular? Let's take some non-regular, take its complement. That is also non-regular, but when you do that L union L complement, what happens? Sigma star, right? Take any non-regular, let's say A power n, B power n, and its complement is also non-regular. You know that when you do the union, you will get A plus B whole star. But did you get a non-regular? No. Non-regular union non-regular, you got regular also. Here need not be non-regular. Sometimes non-regular, sometimes not regular, sometimes regular. Need not be non-regular. Okay, this is an example to understand the union of two non-regulars can be regular. Okay, and second, non-regular minus non-regular may get even regular. Let's take the same example: A power n, B power n minus A power n, B power n. You get empty language. That's regular, right? It also need not be. And intersection, which one you will take? A power n, B power n, intersection B power k or something like B power k, A power k. Now what happens when you do the intersection? You'll get only epsilon is the common, but this is a regular. You took two non-regulars, but you got a regular. Here also need not be regular. If you want a non-regular, take the same language, then you will get non-regular also. And subset of non-regular. Subset of non-regular. You take a power n, b power n. Its subset, I can write even empty language is a subset. But empty language is not non-regular, it's a regular. So all of them need not be non-regular. Here also you don't have any closed operation. (91). Now we need to identify closed for finite languages. Easy. Finite languages, when they ask, it will be very easy for you. Finite union finite. Finite minus finite. Finite intersection finite. Subset of finite. Have the answer with. Complement. Aris. Non-regular complement is always not regular. Yes, is there? Good question. If you take any non-regular, do the complement, you will always get non-regular. Not explaining, as you know, it's a very. Now, let's see who will answer the statements. If A is regular, then what can you say? B is some language. Assume that B is language, but not mention which language. That's it. A is a regular language, but B is, we do not know. Else that you have need to think about. Reversal of infinite is again infinite. That is, take infinite language, do the reversal, you will get again infinite. Likewise, you may have it, but you should think about it. So we study regulars, we don't study non-regulars closure properties, no? So you may not aware of that exactly. Regular language union some language B, what will be result? Can you guarantee regular? Need not be regular. B is unknown, right? B is regular, then answer will be regular. But if B is not regular, the result could be anything. So we don't know what happens when regular language union with unknown language result can be anything, right? Which one you will choose? Any idea? Which one you will choose? Any idea? Can you choose regular? No. Can you choose not regular? No. Can you choose finite? No. Can you choose infinite? No. All of them are wrong. This is what your knowledge will be tested. If you are just blindly answering, then you will choose one of them. But when you understand, you will know that there is no option. Okay? Very easy question, no? Now, you already have an answer. A and B are two non-regular languages. Then what happens? A union B. Non-regular, you have to take one union. I already explained this concept. Union for non-regulars. What happens? Can you answer always regular? Regular means always regular, because just mentioned is dash. Then say is possible, that is a different. Non-regular union non-regular. Again, it is possible either regular or even it is possible not regular. Then we can't choose only regular. We can't choose only not regular. Here there is no option matching, correct? Wait. This time could match. Any idea what can it match now? It may be regular or not regular, but something happens now. Every non-regular, can we say infinite? Every non-regular we can say infinite, because finite is always regular, right? Every non-regular has to be infinite. Infinite union infinite, but we can guarantee always infinite. So this matches now. Previous one was different. This one is different. The previous one, can we go back? Did we miss that concept about regular? If this could have been given non-regular union B, we can guarantee infinite. Okay, understand the point? If this is non-regular, suppose A is non-regular, then you can get the logic always infinite. Okay, you can keep this is a really different question. Just closure property now. We don't need much time for this. A and B are regular. Then what is A union B? We can guarantee regular. We can't guarantee. There's impossible to be not regular. We don't know finite or infinite. It's anything is possible. I'm not giving you time. Go for this. A union B is regular. So result is regular. That's all we know. We don't know about A and B. What happens to this A? Can you tell me what happens here? This is may or may be regular when it may be not regular. So we cannot answer any of this here. Cannot say even finite. It may be finite. Yeah. May, but we cannot guarantee always. May infinite. We are not sure about any of these options because they are not always. You should choose only always regular, then you should choose it. Sometimes regular you can't. Okay. A union B is non-regular. That's all we know. But we don't know about A. Can you talk about A? What happens? If A union B is non-regular, then A, can you guarantee regular always? A, can you guarantee not regular? Can you guarantee finite? Can you guarantee infinite? Because of capital B, A will get a lot of choices. Right? If A is regular, then B can be non-regular to get a non-regular. Correct? If A might be non-regular, we don't know. A might be finite, A might be infinite. Again, more possibilities may come. A again will not match with any of this. Again, none of this. Again, none of this. You can try. If we take A is regular, still we can prove non-regular. If we take A is non-regular, still we can prove non-regular. A, you can get anything. Now, A union B is a finite language. We don't know about A, we don't know about B, but the result is finite. We only know union is finite. Now, what happens to this A? Can we say finite? Can we say infinite? Can we say regular? Can we say not regular? Now you have good question. You can say something now about A. Previously you were not able to conclude, now you can conclude. Tell me, the result is finite. Is there any time, is this possible to be infinite? You know, infinite union, anything is infinite. You will never get a finite. A never be infinite. One conclusion we can answer it, it cannot be infinite. Never be infinite. We know that point now, conclusion. Because we want union is finite, then A cannot be infinite, B cannot be infinite. So A has to be finite. If it is finite, then it has to be regular also. Right? Only we are talking about A. A is a finite, we know. Because of the finite, every finite is what? Regular. We cannot take blindly every regular, but what we can say, A is definitely regular, but that should be finite type. Okay? A is definitely regular, no doubt. If A union B is infinite, now can you talk about this A? What could be it? We don't know about A and B now. A, is it always regular? It not be. To get an infinite, I can take two non-regulars, I can prove. Is it always not regular? No. I can take even regular. Infinite language also, there are some regulars that I can take, I can prove infinite. And finite. Always? No. I can take infinite also here. Can I take infinite? I can take even finite, but I will take infinite, then I will prove it. Again, this time none. No option you cannot prove always. (99) A minus B is not regular. Non-regular, not regular, both are same. Now what is this A? Can you say something about this A? A minus B is not regular. Can you say A is regular? Need not be, right? I may take even non-regular here. Right? A, let's say A is A power n, B power n, B is a pi language. A power n, B power n minus pi is not regular. Okay? Is it always not regular? Think about it. No, I may take even regular. How? I'll take A plus B whole star. Here I'll take A power n, B power n. A plus B whole star minus A power n, B power n. It's a complement of A power n, B power n. That is also not regular. So you can take regular, you can take non-regular, finite. Oh, if I take this a finite minus what? B, can you prove not regular? It's never be finite. Can I take finite here? Finite minus anything in the world is a finite, right? That means you can understand something. This should never be finite. If this is a finite, result will be finite, so regular happens. Now you got the concept. This should be infinite only, but which infinite we are not sure. It may be regular infinite or non-regular infinite. So we can only conclude infinite. Very good question. Done? So now I will give you one question. Try it on your own. If A is any language, we don't know, some language over some sigma, okay? Then prefix of A. First you should find prefix of A, then for that again prefix operation you should apply, okay? Is it equal to A? Remember, prefix of A. Now complement of A. First you should apply complement over the A, then again you should apply this complement, okay? So will you get back to A? And reversal of A. First you should apply reversal of A, then again you apply reversal over this. Will you get A? Check it. Can you do it as homework and put in the comment section? I'll check, and next class also I may discuss if you have any doubt. So this is the homework question for you, and write. And again tomorrow you have the free session at 6 AM. It's TOC Finite Automata practice is there. If you want to come for Finite Automata practice, you may join. In 7:30 AM you have TOC and CD compiler revision. If you have any doubts, you can bring them, we'll solve it. And tomorrow again we have session 10 PM. We'll continue the series, 300 question series for TOC. This is scheduled for tomorrow. All are free. Right now TOC crash course is started recently, just I think 4-5 classes only completed. Yes, all are Unacademy free only, right? Just what you have to do, visit my profile and there you can access all these classes freely, except this one. This is a YT. It's on YT. It's an app. Free classes that Unacademy app you can download and start watching this free classes. And this is the batch which is recently started for TOC. This is a data science and computer science. The TOC is started here. You can see that. Every day 8 PM is going on, Monday to Friday. Tomorrow, Sunday you don't have the sessions for batches. And new batch is going to start from 25th August for data science. The Python programming is going to start. And also you have orientation and strategy session by Sanjay sir at 9 AM on 25th August. And for 2026 aspirants also you have the batches. And for computer science, same day is going to start the batch, 25th August. The first subject is digital logic. And for 2026 aspirants also same subject is going to start. And in case if you are interested to take the subscription, you want to prepare from now onwards, then you have, if you are targeting 2025, I think 6 months would be sufficient. If you are also preparing for 2026, then go for 12 months. The offer is valid till 25th August. Okay. The code that you should apply to avail this offer, you may see the price is higher than this, but to bring the price to this amount, you should apply the code CSDA. And also you can attempt this scholarship test to avail the scholarship on 25th August. To register for this test series, scholarship test, you can scan this QR code and you can enroll for this test. And at 11 AM you need to attempt this test. Duration is 30 minutes. Total 20 practice questions. And in case you have not taken any test series so far, definitely you have a good test series, that is 103 test and 3 to 5 4 5 questions. Really more than 3000 questions are there. Will help you to prepare the GATE concepts very well, because of you will have a lot of practice here. You can understand what questions you are doing mistakes and you can correct them, because you have a lot of different questions will be there. Right? Yes, if you want to enroll, you have 1499 price for this. The code is again same everywhere. CSDA, you should apply for it. Yes, if you require. When data science also another test series is there available, you can also, if you really require. This is my profile. Go to here, and then if you want to join free classes, you can join me tomorrow 6 AM and as well as 7 after 7. Thank you so much. then tomorrow with the new question. Bye. Batch is already taken.